Now, let's look at an important application of derivatives, velocity and rates of change. Suppose the position of an object is given by the function s of t, where t represents time. First, we define the average velocity. The average velocity from time a to time t is s of t minus s of a all over t minus a. This formula tells us how much position changes over a period of time. In other words, it measures the average rate of change of a function. But sometimes we want to know the velocity at one specific moment, not over an interval. This is called instantaneous velocity. Instantaneous velocity at time t equals a is written as v of a equals s prime of a. So the instantaneous velocity is simply the derivative of the position function. This means the derivative tells us how fast the position is changing at that exact moment. Now, let's look at an example. A rock's height is given by s of t equals negative 16t squared plus 64. Here, s of t represents the height of the rock. T represents time. We want to find the instantaneous velocity at t equals 1, which is v of 1. V of 1 is the derivative of the position function at t equals 1, which is s prime of 1. To find the derivative of the function, we use the limit definition. S prime of 1 equals limit as h approaches 0 of s of 1 plus h minus s of 1 all over h. I will find s of 1 plus h and s of 1 separately and substitute them back into the formula. To find s of 1 plus h, I substitute 1 plus h into the function. So I have negative 16 times 1 plus h squared plus 64. One plus h squared equals 1 plus 2h plus h squared. So I have negative 16 times 1 plus 2h plus h squared plus 64. I'll take negative 16 times 1 plus 2h plus h squared, which is negative 16 minus 32h minus 16h squared. And plus 64. Negative 16 plus 64 is 48. So I have 48 minus 32h minus 16h squared. So S of h plus 1 equals 48 minus 32h minus 16h squared. I will replace this with 48 minus 32h minus 16h squared. Next, I need to find S of 1. To find S of 1, I will substitute 1 into the function. So I have negative 16 times 1 squared plus 64. One square is 1, and 1 times negative 16 is negative 16, plus 64. Negative 16 plus 64 is 48. S of 1 equals 48. I will substitute S of 1 with 48. So I have limit as h approaches 0 of 48 minus 32h minus 16h squared minus 48 all over h. Next, I need to simplify the numerator. 48 minus 48 is 0. So in the numerator, I'll have negative 32h minus 16h squared. All over h. We factor out h from the numerator. And then we'll cancel h. Now I have limit as h approaches 0 of negative 32 minus 16h. I plug in 0 for h. 16 times 0 is 0, and negative 32 minus 0 is negative 32. So v of 1 equals negative 32. That means the instantaneous velocity at t equals 1 is negative 32. The negative sign means the rock is moving downward.